quick the first time and then.
Yeah, I do too.
All right.
All right. So given the linear equation, what is the y-intercept? So that's 2.0, right?
I don't have it open yet. Yeah.
Oh,
Yeah.
that's the first part.
Yeah.
And then the slope is 1.5. What's the predicted value of y when x equals 16? Okay, so for that one,
So it's like 7, I think, because 0.25
just,
times 16 is 4. I think it's 7.
negative 3 though,
Oh, so
right?
1? Yeah, no, you're right.
So negative
So yeah,
3
it's 1.
plus 0.25 times 16 is 1, right?
Yep.
Okay. It says round to 1 decimal, but would we put 1.0 or are we
Yeah,
wrong?
that's what I put, but I don't. It's the same thing. So
She always gets me with that stuff because it makes me question the
right.
answer. Ugh. Okay. Yeah, it's just 1. Okay. All right, make a scatter plot of the math self-efficacy data of the 3 data shapes introduced in the reading. Data shapes? Did we read about data shapes?
I don't remember seeing
Did I
anything
miss
about.
something? 3
I don't
data
remember
shapes.
seeing anything about data shapes. So I'm looking at right now.
Oh, okay, here it is. With the manatee information, it has hot dog, hamburger, and banana.
Oh, okay.
I guess I missed that. All right, so I need to pull up the. Hang on, let me see if I can get my SPSS to come up.
Yeah, that's what I'm doing too.
And it was math self-efficacy, right?
Yes.
Okay. Well, maybe. It's coming up slowly. Sorry.
No, you're good. Mine's not moving much faster, so no worries.
Okay.
Let's see.
So if we need the shape, we need to do a scatter plot, right?
Yeah. Trying to remember how to even do the scatter plot.
So the question was what? Make a scatter plot of the math self-efficacy data of the 3 data shapes. It doesn't really say the variables and stuff.
Let's see.
All right, so let's see. If we take it how it is and do graphs, legacy, dialogues, scatter, simple scatter. I guess we put gender on one and no. Score on one and confidence rating on the other.
Yeah, that sounds right.
And okay. Well, okay, here it goes. Okay.
It looks like hot dog.
Hot
Or maybe,
dog. Let's see.
is that a hot dog? Yeah, I think it's a hot dog.
I don't know. Because it's not concentrated enough.
Yeah.
I don't remember the shapes now. I have to go back to the lesson. Probably.
Looking at the shapes, I think it's a hot dog.
Oh, yeah. Yeah, it's not the hamburger one for sure.
Mm-hmm. All right.
That's so weird. Okay. Strange question. All right. So we're going to say it's a hot dog. Based on the shape of the scatter plot you produced in question 6, what can you say about the appropriateness of using simple linear regression to model these data? I think I said it's not appropriate, but what is the question? What does it say? Oh, no, it says conduct regression analysis to determine if there is a significant linear relationship. So,
I think, wouldn't it be appropriate for this?
yeah.
Okay.
Yeah, the last one. Okay. How many observations are in the mass self-efficacy data? How many observations?
I gotta be honest, I don't even remember what that means. Observations.
Are in, right? It looks like when you go to the data view, it looks like there are 139 lines of data. Let me see.
Yeah, that's what I would guess. Is that all
Yeah,
it is?
it
It's
says
just
a group of n equals 139 students participated in the survey.
sounds good.
So I guess
139.
it would be 139. We didn't go over that with the. Oh my gosh, I have bronchitis now.
Oh, you have bronchitis? Oh
Yes.
man, that's.
Sorry. Okay.
No, don't worry about it.
All right, so they want us to do the intercepts and stuff. So we have to go back to the data and do the regression thing
Okay.
on the data. So we go to analyze, regression, linear, and then what did it say to use as our dependent?
You do. I
Confidence
just listened
data.
to it.
Confidence for the explanatory variable, which means confidence is the independent variable.
And then the score would be the dependent.
Confidence is the independent and score would be the dependent, right?
Yeah, I think that's right. And then you go to save or whatever.
That's score. And then, yeah, that's all we have to do on that. Then you just hit OK. We only go to save for predicted value.
Okay.
So, okay, so what's the actual question that we're doing? What's the y-intercept? Okay, so y-intercept is going to be the thing under constant. So 18.690, is that what you got? Under the
18.690.
what do you have under coefficients and then constant under the B column?
Oh, I do have 18.690.
Okay.
Looking at the wrong thing.
That should be our y-intercept.
Okay.
18.690.
The slope.
Right, 18 point, yeah, and then slope should be 12.695. Is that what you got?
Yeah. Yep.
Okay. 12.695. What's the predicted value of y when x equals 4? So that's going to be 18.690 plus 12.695 times 4,
Times
right?
4, right? Yeah. 12.6 times 4 plus 69.47 is what I got.
Yep, that's what I got.
How you got? Cool.
9.47. Confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What's the maximum predicted value of y for these values of x? What?
Because there's
We can use the largest x value to find the largest predicted value of y.
So would we just plug in 6 like we had 4?
Maybe. What's the maximum predicted value of y for these values of x? I'm not sure about that. Let me see if the textbook
Yeah. So I'm trying to do too. Look in the notes.
prediction. I don't see that in these in the textbook. Okay, sometimes it's necessary to use more than one predictor variable. No, not that one.
Right, here we go. Linear regression allows us to predict values of y for a given x. This is done by first calculating the coefficients b0 and b1 and then plugging in the desired value of x and solving for y. So I think we just plug it in. Plug in the 6.
The desired value. Okay, all right. So we would still do the same thing, but instead of 4, do 6?
Yeah, if you have the notes open, just go to the summary at the very bottom, and the second bullet point says that. So
I see it. I guess we'll try it out and see.
Yeah, I don't have any better ideas.
Yeah, I'm good with it. I just want to take medicine and go to bed right now. So
Yeah, I don't blame you.
94.86.
Yep.
Is that what you got?
Yeah. 94.86.
How many explanatory variables are present in simple linear regression? How many? Isn't it 1
I think so.
for simple or no? Let's see. Yeah, it says
Yeah, I think it's
when we want
1.
to refer to simple linear regression, there are a variety of names. If we need to distinguish between simple linear regression and multiple regression, the key will be whether we use the word multiple. If we're discussing regression, the word multiple is not used. We assume we're talking about simple least squares regression.
Okay.
I think we only have one. We only talked about having one variable, right?
I think so.
Let me see at the top of it.
How many responses?
Come on. Simple regression. Oh, wait. Simple linear regression is a method used to fit a line to data. This provides a powerful tool to model bivariate data, i.e. data involving two variables. Regression also No, regression allows us to write a linear equation that models the relationship between the independent variable and the dependent variable, which we can use to predict the value of y for any given variable x. For the crocodile data, the independent variable is length, and we'll use this to predict. Okay, what did the question say? What do you think? You think it's 1?
I thought so, and then thinking about it more, I'm trying to trick myself. I think it's 1 though. I'm not sure about the dependent variables.
Because all we talked about is 1, like body length predicting head length.
Right.
And power boats killing manatees. We didn't talk about multiples. I think it's 1. I don't know.
Okay.
I want to go back to 12 for a second. Hang on. X equals value of y when x equals 4. And confidence was our x or our y?
Confidence was, let me see. I think confidence was the x.
Just want to make sure that, I guess it doesn't matter. If we get it wrong, we're at the end of the semester anyway.
Right.
But confidence is your explanatory variable, which is your x. Okay, I think that's right. So you want to leave it at 1 for 13 and 14?
Sure.
All right.
You ready to submit this?
Yeah, we answered everything.
Let me check.
I think.
Yep.
All right, see what we get. Yay,
Nice.
we got an A.
Sweet.
Good deal. All right, well,
All
I'm
right.
going to do my first attempt on the homework, and then I'll send you an email if I have any questions.
Sounds good.
And then we'll need to talk about the project, but maybe
Yeah,
I
I'll
can
look
email
at
you
it.
about it
I'll
tomorrow
look
or
at it
something.
tomorrow. Yeah, for sure.
Okay.
All right.
Have a good night.
You too. Get feeling better.
Thank you.
See ya.
All right, bye.